Hello students, welcome back to our channel. Today we are going to discuss force and its effects. This is a very basic concept to know about this Newton's law of motion. If you understand this basic concept, this concept will helpful to understand the Newton's law of motion, right? So today's our topic is force and its effect. Okay, what is the definition of force? If anyone asks what is force, what you will give the answer? What is the answer for the what is force? Generally we'll give the general definition like it is a push or pull, right? So why we are using push or pull only for force? What is the reason behind that? See, if you want to change the position of the object or if you want to move the object, either push or pull we have to use, right? So if you want to move one object, either we have to push the object. Okay, if you want to change the object from that position to this position, we have to use pulling force, right? So that is why we are using generally what is force means we will give the answer as push or pull. But actually what is the definition of force? What is the definition of force? Yes, now we will discuss. It is an external cause which changes or tend to change the state of rest or uniform motion of a body in a straight line. This is the actual definition of force. So in this definition, I will underline few words. Okay, we'll discuss about the words first of all. Okay, now which changes or tend to change. Okay, which changes or tend to change means whenever if you apply any force, that body has to change the position or else it tend to change means it tries to change. So what is this different two words are there? How to understand this? Yes, I will give one example to understand that. Okay, now I am applying force on the wall, right? Is it moving now? No. But I am applying force now, even though it is not moving. So what is the meaning of that? It is an external cause which tend to change the state of rest or uniform motion of a body. Means it is trying to change the position. Okay, this is one way. And suppose if I apply any force, this is the object on my hand. I am applying force now. Is it moving or not? Yes, it is moving. So it is an external cause which changes or tend to change, means try to change the position of the object. Either it is in the rest or uniform motion of the body moving in a straight line, right? So this is the actual definition of force. And what is rest? If any object is not moving with respect to time, okay, that is called rest. Okay, generally we will give what is rest means which is not moving. What is motion means which is moving, right? That is not the actually we have to tell. If you know the concept, we have to tell in this way only. What is the rest means? If any body is not moving with respect to time, means at let us consider now at 1 o'clock is there. Time is 1 o'clock. Okay, this body is here only. After a few seconds or few minutes or few hours, this board will be there only. What is the meaning of that? So as the time changes, it is not moving. So this object, this board is considered as rest. Okay, now I am moving from here and there, right? So as the time changes, I am moving. With respect to time, I am moving. So I am in the motion, right? So in this way, we have to give the definitions for the rest or motion. In the same way, what is force? If anyone asks you, what answer we have to give? It is an external cause which changes or try to or tend to change the state of rest or uniform motion of a body in a straight line. That is what the definition we have to give instead of push or pull. Is it right? Yes. This is about the definition. Now, what are the units? So by observing this definition, what is the conclusion we can give? Force is the cause of motion. What is the final conclusion we have to give? Force is the cause of motion. Okay. So force is the responsible quantity for the any object to move. That is what the final conclusion we have to give. Yes, now what is the unit for the force? Unit for the force is what? Newton. Right? First of all, tell me what is the formula for the force? Yes, F is equal to, force is represented with the symbol F. Force is equal to mass into acceleration. Mass into acceleration. Force is equal to mass into acceleration. Mass is measured in kg. And acceleration is, what is the unit of acceleration? Meter per second square. So this is the unit. And it also be represented with the Newton. Symbol is N. Okay. Or Newton or kg meter per second square. This is the SI unit of force. Right? Then what is the CGS unit? What is the CGS unit? Dyne. For the Newton, what is the CGS unit? Dyne. Or gram centimeter per second square. So this is the SI unit of force. What is the SI unit of force? Newton or kg meter per second square. Okay, if you remember the formula, it is easy to get the unit of that. Right? Yes. So CGS unit what? Dyne or gram centimeter per second square. Right? These are the SI unit and CGS unit. One more unit is there, that is not SI unit. What is that? Gravitational unit. Gravitational unit. What is the gravitational unit of force? Yes, that is kgf. kgf. This is not a movie name. This is the unit, gravitational unit of force. kgf. kg means kilogram, f is force. Or also one more, we can call it as same as kg weight. Okay, kgf or kg weight. So gravitational unit of force is what? kgf or kg weight. Okay, this is a other unit, but we want in SI unit. So how to convert this gravitational unit of force into SI unit means 1 kgf or 1 kg weight is equal to 9.8 Newton. Okay. So if they in the problems or anything they will give in kgfs. Then if you want to convert into SI unit, that is equal to 9.8 Newton. So 1 kgf is equal to 9.8 Newton. This is very important thing you have to remember. Okay. Yes. And one more. 1 Newton is equal to how many dynes? They will give in the problems, they will give newtons. But we need to convert into the dynes. So we want to know what is the equivalent value for that, right? So we need to remember this. 1 Newton is equal to 10 power 5 dyne. 1 Newton is equal to 10 to the power 5 dynes. Okay. In the same way, 1 dyne is equal to 10 to the power minus 5 Newton. 10 to the power minus 5 Newton. So if you remember this, this is easy to get the answer, right? So 1 Newton is equal to 10 to the power 5 dyne, right? So these are the units, different units involved in the force. So these are all very important to know, and we have to implement in the problems, right? So as of now we covered what is the force and what are the units, different units involved in the force, right? Yes. Now we are going to discuss what are the effects of force. Because of force, what are the effects we are getting? Okay, that is what we have to discuss now. Yes. Now we are going to discuss about effects of force, right? So these are the different effects we observe when you apply force. Okay. So these are the different effects we are observed when you apply force. What are those effects? Let us see one by one with examples, right? First one is to set a stationary body into motion. What is the first one? To set a stationary body into motion. Let us explain with one example. Okay. Initially this object is at rest condition. If I apply a force on this object, then it is able to move or not? Yes, it is moving. So force can cause an object can move which is at rest condition. Okay. So that is the first one. And second one, to stop the moving bodies. Means after applying force, it can cause the objects which are moving into the rest condition. Okay. Any car is traveling. Suppose if you want to stop that car, what driver will do? They will apply brakes, right? So we have to apply some force to stop the object. That is the second cause. Okay. And third one is to change the direction or speed of a moving body. Okay. So how can we change the speed? By applying force only, no? Suppose initially we are moving with a 10 km/h, that speed we are maintaining. Now if you want to change the direction, we have to accelerate. We have to use that accelerate, right? So we can change the speed of the body by using force. That is the third, right? One more is what? To change the direction also. So if I want to move this direction, I want to apply some force so that I can change my direction. So force is responsible to cause the direction also. And fourth one, to bring about the change in dimension. So these are all is very easy, right? And what is the meaning of this? To bring about the change in dimensions. Suppose take one rubber band. Okay. If you apply a force so that it can stretch, what will happen that rubber band? It will be change the length. Okay. So because of force, we can change the dimensions of the body also. So these are the different effects produced by the force. What is the first one? Overall, I will tell you one more time. What is the first one? It can change from rest to motion. Second one. What is the second one? It can change from motion to rest. Okay, for that also we need force. And third one, we can change the direction or speed by applying a force. That is the third one. And what is the fourth one? To bring about the change in dimensions. Okay, so these are the effects observed when you apply a force, right? Yes, my dear students. Today so far we discussed what is force and its units along with its effects, right? I hope you understand this concept, which is a basic and important topic to understand Newton's laws of motion. Okay, if you like the video, please like, share and subscribe to our channel. Thank you.